arrange your chairs properly. Please be seated. Miss Reyes, is there any absent today? Very good. I have given you an assignment last time. Please pass it forward. Before we proceed with our next lesson this morning, let us recap first what we have learned last meeting. Simply raise your hand if you want to answer. Are we clear? Can you share anything that you learned last discussion? Yes, Mr. Suarez. Yes, Mr. Suarez. How will you define fundamental counting principle? Very good. And when do we use fundamental counting principle, Mr. Dison? Yes, you're right. Do you have any questions about our previous lesson? Is everything clear? To begin our discussion, let's have an activity entitled 1, 2, 3, Blitz. Is to write every digit 1, 2, 3, 4 without repeating any digit. On the board, I draw a table with 24 rows, so it means you need to fill 24 possible sequence of order without repeats. Those who want to answer, just go to the board and write. Is that clear? Are you ready? 1, 2, 3, 4, blitz! Now, how do you find our activity? Class, take a look at the activity. Is the order or arrangement of digits are important? Can you explain how it become important? Very good. So when doing that activity where order or arrangement is important, what do you call each possible arrangement? That's right. Before we formally begin our discussion, first, let's read our objectives of lesson 2 for today. Everybody kindly read the lesson objectives. Instead of listing all the possible arrangement, mathematics has easy way of solving problems which is concerned with arrangement, and that's called permutations. So what is permutation? How to solve involving permutation? Let's define permutation. A permutation is an arrangement or listing of objects in which the order is important. Permutation is used when we are counting without replacement and the order matters. There are different permutations. One of those is linear permutation. This formula was used when distinct object n taken r at a time. Let's have an example. In how many ways can a committee of 7 students be chosen from 9 juniors and 4 seniors in a committee? The n is the number of juniors and seniors in the committee, and r is the number of students chosen. Using the formula, can you solve the problem? Who wants to solve the problem? Yes, Mr. Dinas. Good job. Did you get the same answer? Another permutation, there are also distinguishable permutation. This permutation was used when there is a repeating objects where n is the number of objects and the q sub 1, q sub 2, and so on depends on the object that repeats. For example, find the number of distinguishable permutation of the letters of the word educated, where n is the number of objects and q is the number of objects that repeats. Now using the given formula, who wants to solve on the board? Yes, Sir Nagal. That's right. Who get the same answer? Very good. Moving on to the last permutation called circular permutation with the formula p equals n minus 1 factorial. This is an arrangement of objects in a circular form. For example, a bracelet has 8 charms. How many arrangements of charms are possible? Using the formula, let's substitute 8 when we obtain 7 factorial, which lead us to the 5040 arrangement of charms. Let's have more example. How many possible arrangements can be made by 7 students in a circular table? On the board, who wants to solve using the given formula? Yes, again, Mr. Dudas.
Salate.
Correct. But how to solve problems with conditions or restrictions? For example, in how many ways can 8 people be seated around a circular table if 2 of them insist on sitting beside each other? Using the circular permutation, substitute n minus 1 factorial, we obtain 7 factorial. And then, we multiplied 6, which is the number of people excluded the number of people who want to seated beside each other, multiplied by 2 factorial, which is the number of people who want to be seated beside each other. We obtain the product 1440 arrangement. In this problem, there is restrictions where they are sitting beside each other. How to solve this? Yes, Ms. Pabo. Very well said. You're right. Do you understand? Are we clear? How about solving problem like this one? In how many ways can 4 men and 3 women arrange themselves in a row for picture taking if the man and woman must stand in alternate positions? Who wants to answer? Yes, Ms. Satya. Who get the same answer? Very good. Well done, class. You all did a great job. Now, how do you find our lesson for today? Once again, how to determine if a situation involves permutation? Very good. Can you differentiate the different kinds of permutations? First, linear permutation. That's right. How about circular permutation? Very good. How about distinguishable permutation? Excellent. Great job, everyone. Now, knowing to solve problems involving permutation, let's have a group activity. Please count 1 to 3 and each group will be given different set of problems. You will be given 10 minutes to work as a group and then after each group will be present the answer in the class. Do you have any questions about the activity? If no questions, you may now proceed to your respective group. Now, let's have a short quiz. Answer each permutation problem completely. Everybody kindly read the quotation. Yes, Let's keep in mind that time is a wonderful way of our arrangement of showing us what really matters. Keep faith in yourself and trust the process. When the timing is right for you, it will come all together. Well done, everyone! For your assignment, solve the following problems. Do you have any questions about your assignment? Everybody stand up and pick up all the pieces under your seats and arrange your chairs properly. Perez, kindly clear the board. Thank you. Closing prayer led by Perez. Goodbye, class.